Hi. I think we're ready to get started. Hopefully you guys are ready for a pretty good morning session here. We're here to talk about finding full range signal. The reason this is important is because with today's new vehicles with DSP, they've got equalization, they have crossovers, they have all kinds of basically signal processing that's going on that's going to alter the sound. So if you're trying to add a subwoofer or do a full range system, you need to know pretty accurately what the signal looks like. Another problem you may run into is just changing a set of factory speakers out. You may pull out a set of factory speakers and put in a set of aftermarket, knowing that you've got a better speaker when you put them in, but it may not sound as good as they did with the factory speakers. That can be because of the factory equalization. So to do this, we need to basically figure out what the signal is. So we're going to use something called an RTA. I'm going to walk around here and turn on my iPad for us here. And I'm going to show you what an RTA looks like. An RTA is short for real-time analyzer. And basically it shows you from low to high frequency how much volume of each of the frequencies you actually have. Now, it's very important to understand what you need to use for a source. We cannot merely use music and a microphone and listen to a speaker to see what it's going to sound like. Let's give you an example. So as I turn the music up, you'll see the RTA is showing a pretty motion-packed graph. I'm not sure how much bass is supposed to be there. I'm not sure how much treble is supposed to be there, and it's constantly changing. I can't tell if there's an EQ. I can't tell if there's a crossover. So what I need to do is I need to get a consistent, steady source of sound, and that's called paint noise. Paint noise is equal amounts of all frequencies. You can find the paint noise track on kicker.com under the support tab, or you can actually find it on KickerU on your paid KickerU app that's got the tone generator. So both sources are going to be extremely good, flat, uncompressed paint noise. Now, if we're going to use our phone, we want to make sure we do not Bluetooth. Anytime you Bluetooth a signal, it's going to be compressed. You want to always use a WAV or a FLAC file if possible, or use it directly from the website. So what I want to do now is I want to pull up the website on my phone, or actually I should say I'm going to pull up the app on my phone, and I want to see if I have a true paint noise signal. So what I'm going to do is I'm going to plug it into the RTA, and we'll explain all this in just a minute, how it works. But let's go ahead and turn on the KickerU app as the phone decides to go crazy. So we're going to go ahead and mute that. All right. So going to KickerU, we're going to turn on our tone generator. So as we go to the KickerU app, we'll go ahead and click tone generator, and we're going to click on paint noise and start. So what I want to see is exactly what we have on this screen here. I've got an equal amounts of all frequencies. As I turn the volume up and down, you notice it stays very consistent. And that's coming right out of the headphone jack of the phone. You know, it's a little roll off here at 20K. That's actually the filters that are in this iPad, but that's still a very usable, very good signal. As I turn the volume back down, if you notice, it's still a flat frequency response. Now, if I go all the way down, you're going to notice just a little bit down at the bottom. That's system noise. We've all heard of engine noise. As long as we turn this up above that level, we should not have an issue with the engine noise or the system noise. All right. So going back to paint noise, we're going to turn it up a little bit. So I know for a fact right now, I've got a great source of paint noise that I can use from my phone. The other thing you can do is you can put it on a flash drive, download it from the Kicker site, put paint noise on your flash drive. The paint noise that's on the website is a 20-minute long track of uncompressed paint noise. So let's go ahead and switch back here to the music. And let's go ahead and turn that music back on from the head unit, preferably. And of course, the phone likes to go back into mute, so All right. So now what we've got going on, we know where we've got a good pink noise source, so let's go ahead and measure the speaker output from the radio. So to measure the output, what we're going to do is we're going to make a little device here, which is actually very simple and very interesting. So this device consists of, pretty simply, a set of test leads, like you'd find on any multimeter. We're going to then take that signal and run it into a kicker KISLOC. This is a line output converter that blocks DC offset. We have separate left and right adjustment. And what I've done is I've taken both negatives and tied them together to the negative lead, both positives tied together to the positive lead. So I've basically monoed out this KISLOC. From there, we're going to go from an RCA to, get to the end of this long cable, a 3.5 jack. Now is the magic tool. This is very similar to the KISLOC. This is a mic to line adapter. So this takes it from the line level down to mic level, and it's going to give me the sleeve for the microphone input. Now with any free or any paid RTA app that you have on a tablet, on a phone, or a laptop, we can plug this into the microphone input, and you're going to see on this particular unit, it switched to headset microphone. Now I can use these leads to probe to find what exactly signal is coming out of or going into the speaker, because we can't use the microphone. In fact, let's go ahead and do that. Let's go ahead and plug this into the speaker output of the head unit. This is also another place where I need to check to make sure that I have and watch your volume too. So now I'm playing pink noise. This is measured right from the audio output. Let's see what it looks like if I'm using the microphone. Very different. That's the microphone. As you see, it changes with my voice, using the microphone to listen to that speaker. Very inaccurate. You can't use your ear. You can't use the microphone on the tablet. You have to use a direct hardline source. Now I've switched up back over to the headset microphone. If you notice, that signal is not flat, and I'm connected directly to the speaker output of the radio. So what I'm going to need to do is I'm going to need to figure out why I'm not getting a flat output. So let's go back to your audio control on your radio. Make sure everything is set flat, preset EQ. You notice how that changes everything? That's how you can tell if you have a pre-programmed equalizer. We're going to go ahead and set that flat. Go back to bass boost. Turn the bass boost off. Loudness. Make sure the loudness is off. Now, if you notice, I know coming out of my head unit, since I've tapped directly into the speaker leads, I have a flat response coming out of the head unit. I know I can use this as a flat signal. Something you may have noticed on the back of the radio, tapped into the speaker leads, I've got one of these, which makes it very easy. It allows you to clip this over a wire, screw the pin in, and that pierces the wire without having to cut into it. Then you plug your test probe into the end, and it makes a very simple, easy contact. So now we know our head unit's got a flat source, it's got a flat output, we're dialed in. Now let's amplifier to see what it's doing. So what I'll do is I'll disconnect these leads. I'm going to plug them into the amplifier output. And if you notice, I've got a pretty flat response once again, and that's coming directly out of the speaker output, out of this IQ amplifier. If I turn the EQ on, this is once again representation of an EQ that's built into an amplifier or a factory head unit. Equalizer I can turn on and off. Connect the output of the speaker. We don't need to listen to it while we're doing the rest of the demonstrations. All right, that should make it a lot quieter, a lot easier to understand. All right, so now let's take this signal. Let's play with this a little bit and look at the different type of signals that you may get in your setup. So let's go ahead and turn the EQ off. Now we should have a flat frequency response. And if I get my assistant Aaron to move that window off the screen, I cannot see the tablet. So let's go ahead and turn on a high pass crossover at 24 dB per octave. Now, if you notice what's happening to that graph, that is showing a high pass crossover at 150 hertz. Let's go back to a full range signal. Once again, usable full range signal. Let's go turn on another crossover. Let's turn on a low crossover. Now, low pass crossover, you see it's starting to roll the high frequencies, and I still pass the low frequencies. If I'm just adding a subwoofer to a stock system, and this is the signal, as long as the frequency is higher than what you're going to cross over the aftermarket equipment at, you can use this to just add a subwoofer. But if you try to use this for a full range signal, it's not going to be adequate. So playing with the crossovers, once again, let's go back to this high pass crossover, turn it on. What if I had this signal? So now I think we lost our display here. So if we look at this signal, I've got a high pass frequency at a high pass point, more like a mid-range or a tweeter crossover. That is not going to be an acceptable signal. So once again, we can change the way the system looks by changing the crossover, and we know exactly what wires we need to tap into. So let's do a high pass crossover to 150 hertz. Let's do a low pass crossover at, say, 3,500 hertz or 2,500. Turn that on. Now what you see is a band pass. This is passing just a band of frequencies, which is very common in a high-end, three-way system. You got a woofer, which is going to be low pass, a mid-range, which will have a band pass crossover, and then a tweeter, which will have a high pass only crossover. So this will give you the availability to measure a signal using this simple little device and a free app, and allow you to probe every single speaker lead to find out which is. In fact, a little horror story, there's a car out there, and I do not remember the year of the, but one of my dealers reported to me they were testing a Lexus, and this was a few years ago. The Lexus had 17 speakers in the car. The only two full-range channels were the mid-bass and the doors. They used the natural roll-off of the 6-inch woofer in the door for the crossovers, but that actually had a full-range source they could then take and use to do a high-end audio system without having to use any type of a summing device. So, pretty simple, pretty easy, but I honestly think this is one of the most important tools besides your screw gun you're going to have in a shop. You need to use that RTA. You need to measure the outputs, because it might sound like it's got a lot of bass coming from a door, but if that signal rolls off, you will not get that proper subwoofer output that you're looking for. The system is not going to be playing to its full potential. So, with that, Aaron, do we have any questions we can answer?
I am looking, and so far no one is asking any questions. You're covering all of the details.
So you guys must be speechless out there or asleep, or I think we covered everything you need.
The bass roll.
And Aaron just mentioned bass roll-off. As we were talking about when playing the paint noise through the head unit, if you turn the volume up and down, if you remember when we did it at the beginning of the presentation, that signal on the RTA actually moved flat. But if as you turn it up, the bass stops and everything keeps going, you have auto bass roll-off, which is common in a lot of factory radios that do not have subwoofers. And in fact, even some of the systems with subwoofers have bass roll-off. But what I suggest to do in a situation like that is you want to get what we call the key 500.1. The 500.1 does take in consideration that bass roll-off and compensates for it. It will also flatten out the frequency response of the little bit of boost they generally put between 60 and 80 hertz. And we will be doing a whole video on that key 500.1 in the future. Actually, the very, very near future, because that's going to be a piece that'll compensate for that bass roll-off. It's full active, and it works out absolutely incredible. For the meantime, if you have a system that has roll-off and you're wondering how to set the gains, turn the volume of the factory radio up to the point where the bass starts to roll off, stop at that point, and that's where you set the gains on the amplifier to reach maximum output. And we'll cover that in the session when we actually show you a oscilloscope and show you how to measure clipping with an oscilloscope and an RTA. So any other questions out there, guys? Like I say, quick and to the point, under 30 minutes, but we know you guys got a lot of, hopefully got a lot of cars to work on, a lot of installs to do, and some money to be made. And I hope this helps you guys. Simple, very easy. But once again, that RTA is going to be one of the most important tools you have in your shop today with the DSP that's built into these new factory audio systems. With that, I think we're going to close out. Thank you, guys. Nope. We've got a webinar Q&A document. And Aaron, do you have the page that shows the email addresses? And if you guys have any questions or run into any questions in the future after this webinar is done, please feel free to email me, Aaron, support@kickr.com. We're happy to answer any questions you may have. Just remember, if you're going to do the home belt RTA like I showed, this is your most important cable. That is the line to mic adapter. It sells for about 20 bucks. If you find one online that's $3 or $4, it's probably not going to have the resistors or the microphone input. But this is the key that makes this work. We literally plug it into the 3.5 jack on the headphone, and now I can probe any speaker lead out of any radio, any amplifier, factory or aftermarket, and know exactly what signal it's producing. Once again, guys, I hope this was entertaining and informative. If you have questions, reach out to us. We're here to help. We're all in this together.
Oh, there's a question.
Aaron has a question.
Michael Perez says, which RTA program are you running on the iPad?
Okay, Michael, I'm actually running an RTA program called Octave RTA. It was $5, and people ask, why did I choose this particular program? It was the first one that popped up when I decided to research, and it works out extremely well. Now, in some of the older iPads, it's not compatible. I've got a 30-pin iPad that I wish I could still use this program. It will not. But a couple cool things that this program does for us. Let's see if we can go back in and suppose I could hit the right source. Some music here. Standby radio, USB. Here we are. It'll allow you to change the averaging speed. Let's go ahead and unplug this and use the microphone. So with the Octave RTA, I can slow it down so you get a very slow reactive state. I can speed it up where it's very fast. I tend to use the medium. You can also do different graph styles. You have peak hold, which you see the little dots, or you might see the little dots on the webinar. I'm not sure, but if you have you'll see it. Something else that's kind of interesting is I can come in here, I can pick a frequency. I just picked 315 hertz. It'll tell me how loud that is. It will also tell me in this corner which frequency is the loudest and how loud that frequency is. So for a $5 program, it's actually really cool. And it will do a 6th octave. 3rd octave is most common. So we have full octave, which every time I go up a bar, it doubles in frequency. 3rd octave, every 3rd bar, it doubles in frequency. And 6th octave, every 6th bar. That's got more resolution than is really commonly used. Most commonly, you're going to see 3rd octave RTAs and 3rd octave equalizers.
Somebody asked about the build sheet for the cable you're using. I'm going to put it up on the screen.
Okay. Yeah, you can find that on the Kickr Tech site. If you scroll to the bottom of the main page, there's a Tech site tab. Click on that, and you'll see another section called White Papers. There's one called Building and Using an RTA. It tells you how to build this exact device and how to use it. So it's pretty simple. You're going to have probably 50 bucks in materials, but like anything else, to do a job right, you got to have some tools. It's not an expensive tool. There are $2,000 RTAs out there that do a very, very good job, but this is extremely accurate, very affordable, and it's going to get you the signal that you need to tie into your system, whether it's just a subwoofer or a full range system.
Okay, John, let me check for any other questions.
See if we got any more questions.
Andy's asking, please list the parts John's using for his kit. Can you go through all that?
Yep. All right, Andy. So the question was, what parts are we using for the kit? So let's go back through it once again. It's pretty simple. any set of meter test leads, a kicker KISLOC. Like I say, very good, high quality. The reason I suggest ours, not just because we work for Kicker, but we do, but a couple other reasons. This is flat frequency response from 5 to 50K with 55 watts power handling. Most line output converters, as you run more power through them, they start narrowing the bandwidth, so you start losing the low and high frequencies, so it's not very accurate. These you can actually test at full power, 55 watts, still have a perfectly flat frequency response. So you have a set of test leads, about 10 bucks. The KISLOC, about $25 retail. A set of RCA to 3.5. That cable's going to run you about $10. And then this is the most important cable. That is the line to mic adapter. In fact, this one's made by a company called Headset Buddy. You might Google that as well, but it sells for $20. I found them for sale on about 5 different websites and Amazon and eBay and several other sites. They're generally all around the $19.95 to $20.95 price point. And this is the magic cable, allow it to plug into the iPad and make everything work. So what do you guys think? Think this help you out? Like I say, in my opinion, for doing installs over the years, this is probably the second most important tool you guys are going to have. Second, probably to your screw gun and maybe your brain. So have some fun out there, guys. Like I say, use this. Make sure you know what you're tying your system into so you can maximize your performance so you don't get customers coming back and say, hey, I just added this 12-inch subwoofer and it just doesn't have the output I expected. Well, if that's the case, you got one of 2 problems. 1, you either didn't tie into the right signal, or 2, you didn't use Kicker product. Nudge, nudge, wink, wink. Thank you, guys.
Would you remind them to email us with future webinar ideas?
Yep. Also want to point out, if you guys have any future webinar ideas that you'd like to see, I mentioned we're going to do one on the Key 500.1, and we'll do one on using an oscilloscope for finding clipping. So anything else you guys think could be beneficial you'd like to see from us, please feel free, email us at support@kicker.com, jmyers@kicker.com, or amalin@kicker.com. And I think Aaron put that up as a handout that you guys can download and get that information. And if you guys are dealers, obviously you know how to get in touch with us pretty easily. And if you can't remember any of these or didn't download, just get in touch with your rep. They'll get in touch with us and we'll get you guys fixed up. Have a great Tuesday, and we'll talk to you guys real soon.